Pick any number. Now add 1. You can always add 1. Numbers never, ever end. But here's the strange part. The universe does end. It has a size. It has a limit. And numbers do not. Which means there are numbers so large, reality itself cannot hold them. Tonight, we're going to meet one. This is the human code. File 5. The number that breaks reality. Part 1. The ladder. Let's climb. 1,000 is easy. 1,000,000, a stack of cash. 1,000,000,000, more seconds than most people ever live. 1,000,000 seconds is about 11 days. 1,000,000,000 seconds? That is over 30 years. Same little word, wildly different worlds. 1,000,000,000,000? There are fewer stars than that in our entire galaxy, and we are just getting started. Our brains simply were not built for this. Past a few thousand, every big number just feels like the same fuzzy blob called a lot. Keep climbing, and you reach a Googol. That's a 1 with 100 zeros behind it. A Googol is already a ridiculous number. It is bigger than the number of atoms in the entire observable universe. Here is another way to feel it. If every single atom in the universe became a whole new universe, and you counted all of those atoms too, you would still fall far short of a Googol. Count every grain of sand on every beach on Earth. You would not even come close. A Googol laughs at all of it. That count, every atom, in every star, in every galaxy we can see, is only about 10 to the 80. A Googol beats it easily. 10 to the 80. Write that out, and it is a 1 followed by 80 zeros. That single number counts every atom you could ever see. Part 2. The number you cannot write. Now for a twist. Take a 1 and write a Googol zeros after it. That is a Googolplex. Here's the problem. You could never actually write it down. Not on paper, not on a computer, not anywhere. If you tried to print a Googolplex, 1 0 per second, the universe would end long before you finish the first tiny corner of it. Because there are not enough atoms in the universe to hold all its zeros. Even if you wrote 1 digit on every atom, you would run out of universe. Let that sink in. A number so long that physical reality does not contain enough stuff to write it, and yet it is still tiny. And remember, a Googolplex is still a normal, finite number. You can add 1 to it. You can double it. It is nowhere near the end. There is no end. Part 3. Graham's number. In the 1970s, a mathematician named Ronald Graham was working on a real problem, and his answer used a number so big, it has its own legend. To even write Graham's number, mathematicians had to invent a brand new kind of arrow, a shorthand for powers of powers of powers. To build it, we need a new kind of power, not 2 times 2, but towers of powers stacked on towers of powers. A Googolplex is a baby next to this. Graham's number is so vast that the tower of exponents needed to write it is itself unimaginable. You start with a tower of 3s. Then you use that giant result to decide how tall the next tower is. Then you do that again and again, 64 times. In fact, physicists point out something eerie. If you tried to picture all its digits in your head would collapse into a black hole. Your brain cannot store that much information. The number of steps is so vast that there is not enough room in the universe to even write down how big the number is. Not the number, just its size. And yet, this was not a joke. Graham's number appeared in a serious mathematical proof. Real math needed a number that breaks reality. And believe it or not, Graham's number is now considered small. Mathematicians have since found numbers, like tree of 3, that make Graham's number look like a rounding error. Part 4. Bigger than infinity. Now you might think, fine, just say infinity and win. But infinity is not a number. It is more like a direction, a road with no end. Picture a hotel with infinite rooms, and every single one is full. A new guest arrives. Is there space? Somehow yes. Just move everyone up by 1. And here is where a man named George Cantor lost his peace of mind. Because he proved something insane. Some infinities are bigger than other infinities. That is Hilbert's Hotel. A full infinity that still has room for more. This is the strange logic Cantor was brave enough to take seriously. The counting numbers go on forever. 1, 2, 3. That is one infinity. But the numbers in between, the endless decimals, form a larger infinity. There are so many numbers between 0 and 1 that you can never list them all. Even with forever, It is an infinity that leaks out of infinity. Think of it like this. Line up every whole number against every decimal, and the decimals will always have leftovers. Endless leftovers, with nowhere left to sit. Try to list every decimal between 0 and 1. Cantor showed that no matter how you do it, you will always miss some. Always. That is a bigger infinity. Cantor's ideas were so disturbing that other mathematicians called them a disease. Today, they are the foundation of modern math. It broke his peace of mind. Some of the greatest minds of his day mocked him. Today, we know he was simply decades ahead. Part 5. Why this matters. So why should you care about numbers you can never see, or write, or even imagine? Because they reveal something profound. Mathematics is not trapped inside our universe. It is bigger than everything that physically exists. Numbers do not care about atoms, or space, or time. They keep going, in a place that has no physical size at all, a place made purely of thought. Every atom, every star, every second since the Big Bang, all of it is finite, countable, small, and numbers just keep going, far past the edge. Everything you can point to is finite. The stars, the atoms, the seconds, all countable, all small, next to what your mind can reach. Which leads to a beautiful, dizzying thought. The one tool that can escape reality was invented by creatures trapped inside it. Us. A 3-year-old counting on their fingers is already touching something the universe can never contain. Infinity, in a tiny human hand. And it costs nothing. A child, counting higher and higher for fun, is doing something the whole physical universe cannot contain. Part 6. The edge. There is no biggest number. There never will be. For any number you name, there is always a bigger one, waiting just behind it. Whatever number you can imagine, add 1. There it is. A bigger one. You can do this forever, and you will never, ever run out. Graham's number. A Googolplex. They feel like the edge of everything. But against true infinity, they are basically 0. So next to true infinity, Graham's number and the number 1 are basically the same size. Both are infinitely far from the end that does not exist. Standing next to the endless, the biggest number a human ever imagined, and the number 1 are almost exactly the same distance from the end. No distance, because there is no end. So the next time you feel small under the stars, remember this. Inside your mind is a staircase that climbs higher than the entire universe. There is something gentle in that. You will never finish counting. Nobody ever will. The staircase goes up forever, and it is yours to climb. You will never reach the top. Nobody will. And somehow, that is the most wonderful part. This was the Human Code, File 5. Next file. Why your brain sees faces that are not there. See you in the next one.